Okay, so we are going to find the area of a region between two curves. These are pretty easy problems. You already know how to integrate, so it's actually just looking for the area between two curves. All right, so I have a x and y axis, and I have the graph of two curves. The f of x curve is the black curve is the f of x curve, and the red curve is the g of x curve. Okay, so this is some function that I am trying to, well, two functions that I'm trying to find the area between those two functions, and these are the graphs of the two functions. All right, so the way it's supposed to be worked out, if you look at the bottom here, it would be integrating from a to b of the top function. In this case, the black graph is the top function minus the bottom function, which would be the g of x. And that would be the same thing as splitting this integration up. The integral of a to b of f of x dx minus the integral of a to b of g of x dx. Okay, and that's coming from one of the properties of integrals that we learned when we first started talking about integration. All right, so again, the way you're going to need to do these problems, first you're going to have to graph the function, and you got to figure out which function is the top curve and which function would be the bottom curve. All right, so it's always the integral from wherever your boundaries are, a to b, whatever a and b are, of the top function minus the bottom function. And if you can actually know or figure out the top function and bottom function, is really easy to integrate. Okay. All right, so I'm going to do an example. Example says find the area of the region bounded by the graphs of y equals x squared plus 2, and that's going to be the red graph here. And I'm using Desmos. And y equals negative x. The blue graph is y is equal to negative x. And my boundaries are going to be the lines x equals 0 and x equals 1. So you really should know how to draw an x equals 0 line, which I'm just going to draw on top of the x-axis here. And you also should know an x equals 1 line, which is right here. When x is equal to 1, I'm drawing a vertical line through x equals 1. So you want the area bounded by these two curves. So I'm looking at it's bounded by the red graph here. So I'm going to kind of color some stuff in here. Let's see if I can get this a little smaller here. Yeah. So I want to find this area here. So the area between the red graph, the blue graph, and the two black lines. That's what I'm looking for, the area here. All right. All right, so I'm bounded by the red graph. I'm bounded by the blue line and the two black lines. So that's what area I'm looking for here. All right, so again, my top function is going to be my red graph, and my bottom function is going to be my blue graph. So I'm going to create this integral. So it's going to be integral from 0 to 1. And remember, 0 and 1 are my boundaries. These are my lines here. Of my top function, which is x squared plus 2, minus my bottom function, which is negative x dx. All right, so if I'm integrating from 0 to 1, I need to simplify this x squared plus 2, and it's going to be plus x dx. Now the rest of this is easy. We're using the fundamental theorem of calculus. So we're going to integrate, and then we're going to evaluate that antiderivative at 0 and 1. So the integral of x squared is x cubed over 3, plus the integral of 2 is 2x, plus the integral of x is x squared over 2. And I'm going to integrate from 0 to 1 because I want to find that little area between those boundary lines. So I'm going to put 1 in first. So I get 1 cubed over 3 plus 2 times 1 plus 1 squared over 2. All right, minus, now I got to put 0 in. So I get 0 cubed over 3 plus 2 times 0 plus 0 squared over 2. All right, so 1 cubed is 1 divided by 3 is a third, plus 2 times 1 is 2, plus 1 squared over 2 is 1/2, and minus everything in parentheses here is 0. So I have 1/3 plus 2 plus 1/2. You can use a calculator, or you can actually get a greatest common denominator, and my greatest common denominator is going to be 6. So I'm going to multiply everything by 6. And that's going to give me 1/3 of 6 is 2, plus 12, plus 3, minus 0. And that should give me 14, 17, and we talked about area, square units. All right, 17 square units. Forgot to divide the 17 by 6, so it should be 17/6. All right, and if you want to verify that, remember you can do it old school. It'll be 1/3 plus 2 over 1 plus 1/2. The greatest common denominator is 6. This is the way we used to do it in 3rd grade. It's the way I did it in 3rd grade. 4th grade, 5th grade, one of those grades. All right, so 3 going to 6, 2 times 1 is 2. 1 will go into 6, 6 times 2 is 12. 2 will go into 6, 3 times 1 is 3. So I get 12, 13, 14, 15, 16, 17, 6. So it should be 17 over 6 square units. Okay, that is my answer to this problem. All right, so the next example says find the area of the region bounded by the graphs of f of x is equal to 2 minus x squared and g of x is equal to x. All right, so we are not given any boundaries in this problem, so we're going to have to set the two equations equal to each other and find the point of intersection, the points of intersection. So I've actually done this graph in Desmos, but if you want to find the point of intersection the algebraic way, you set 2 minus x squared equal to x, and you get all the terms on one side. So I'm going to subtract 2. Let me get the right ink. I'm going to subtract 2 from both sides here, and that's going to give me negative x squared is equal to x minus 2, and then I'm going to add x squared to both sides. So I have 0 is equal to, I'm going to write x squared first, plus my x term minus my constant term. And then what I want to do, I want to factor this. So I'm going to factor this trinomial. So I have x and x. The factors of negative 2 to add up to 1 would be positive 2 and a negative 1. And then once I find my factors, I set those factors equal to 0, and I solve for x. So I have x is equal to negative 2 and x is equal to 1. So these are my boundary lines here. And on the graph, I drew those boundary lines in black. So at x equals negative 2, there's a vertical line going through that, negative 2. And then for x equals 1, there's a vertical line going through the 1. All right, and then I'm trying to find the area between those two lines, my boundaries, and also the orange curve and the purple curve, purple line. So the yellow part is what I want to find the area of. So now I just need to set up my integration here. So I have the integral from negative 2 to 1. I remember it's my top curve, which is my orange curve. My orange curve is the equation 2 minus x squared. And then my purple curve is the x curve, y equals x, or g of x is equal to x. So it's going to be my top curve, which is 2 minus x squared, minus my bottom curve, which is x dx. And then I just need to integrate each term. So I integrate the 2, I get 2x. If I integrate x squared, I get x cubed over 3. And if I integrate the x, I get x squared over 2. And I'm going to integrate that from -2 to 1. So I'm going to put in -2 first, and then I'm going to put in 1 first, and then -2. So if I'm substituting 1, so I have 2 times 1 minus 1 cubed over 3 minus 1 squared over 2. All right, and then minus, I'm going to substitute -2 in. So I have 2 times -2 is -4. Minus, I got -2 cubed. It's going to give me -8/3. All right. Minus -2 squared is 4 over 2, which is 2. So I'm going to get 2 minus 1/3 minus 1/2. And then minus, I have -4 plus 8/3 minus 2. All right, so I'm going to actually take this to the side, and I'm going to find the answer. So the answer is 9/2. So that is the area between x equals -2, x equals 1, y equals 2 minus x squared, and y equals x. All right. All right, so there are 5 problems that I want you to complete. And once you're done, I want you to upload them to the Google Classroom so I can give you credit for those 5 problems. If you need some help, you can send me a remind message. Or if you need to ask a question, you can send me a remind message. I'm not going to see anybody until Monday because I had surgery. So I won't be back until Monday. So, and I'll let you know by the end of the week what type of final exam I will be giving next week.